Hey everybody, Greg Stewart here with Maizex Seeds. Welcome to you and everyone joining us from across Canada for our Decipher, Debate, and Decide 2021 Agronomy Series. This week, our topic is strip tillage with fertilizer. Can the planter run free? Our guest presenter today will be Ben Rosser, Omafra corn specialist. Ben has been working for about 5 years now as the new and improved corn specialist and continues to dig into strip tillage issues with some good research work. We're excited to have you, Ben, lead the discussion here today. And joining us for today's discussion as our color commentator is Mike Cornelison. Mike farms with his family in Lambton County here in southwestern Ontario. Now, some color commentators are guys that have hung up the skates a long time ago, but Mike is still very active in sorting out how strip tillage systems can work best on his farm. Mike, it's also great to have you with us today to share your ideas and insights. The first 45 minutes of our session will focus on laying out the information, and this will be followed by an open question and answer period. As the presentation goes along, be sure to use the webinar question box to send questions in, and we will get to as many of them as possible during that Q&A session. With that, let's turn it over to Ben.
Great. Thanks, Greg, and thanks for the invitation to speak. Yeah, I thought I'd go through a little bit as some preface on the topic of some research we're doing right now, looking at strip till fertility, and then move on with some data we've got from across the province from some work we've done, as well as a number of on-farm cooperators, trying to answer that question of do you need starter fertilizer on a fertilized strip? A little bit of background about the project that we're working on right now. It's a GFO funded project, and there's a couple of main questions I've had since starting as corn specialist that I haven't had good answers for. And part of the reason for developing this project is to answer some of these questions that I've had from growers. Kind of one of the first big ones is, when you're comparing a strip till system, how does broadcast and incorporate P and K in a conventional till system compared to strip and strip placed P and K? Particularly, is there more efficiency for banding or mixing amount of fertilizer in that strip where you're going to plant compared to broadcasting fertilizer across the surface, particularly from a P and K perspective? The next question was, if I'm on ground that allows me to strip and apply P and K in either the spring or the fall, so I'm not afraid about going out on my field in the springtime with a strip tiller and being able to make a nicely conditioned strip. Is there a preferred time to do so? Thinking strictly from a yield perspective. Obviously, there's some logistics and time benefits of the different timings, but strictly from a yield perspective, is there a better timing for one or the other? Kind of the third question I really wanted to answer was, if I fall apply P and K in the strip, should I also have some starter P and K on the planter the next spring? So again, if you're putting fertilizer all down in the fall in a strip, is there some efficiency for having some fertilizer at planting timing when the bulk of your fertilizer has already been applied in the strip, or moving a portion of the fertilizer from fall strip to spring planter? And then last, just a general question most growers have when they're thinking about moving to strip till is, generally speaking, what's yield performance of strip till like when you compare it to full width tillage? A little bit of background on the treatments we're looking at to answer these questions. We're applying P and K at about 1 corn crop removal, so we're putting down 60 pounds of P and 60 pounds of K. You could argue that in a real strip till scenario, you could push things more, and that might change your fertility responses a little bit. But again, we want to be somewhat conservative while still representing a reasonable amount of fertilizer you could apply to try to detect differences in efficiencies for different fertilizer placements or timings as well. Also, we're always putting 30 pounds of starter down. So most of the nitrogen in these trials is side dressed after planting, but we always make sure to make things consistent, that we always have 30 pounds of nitrogen down on the planter, always going down in a 2x2 band. Also, we are looking at treatments on soils that for the most part are fairly responsive for P and K. So the majority of fields we're doing trials on are fairly low testing for P and K. Again, we're trying to look at differences in response, so we want to make sure we're on a soil that will show those differences, and if there's differences in efficiency for timing or placement, that those will show up for us. So, and to try to answer these questions, again, I've got a total of 6 treatments. The first 3 are looking at conventional tillage or full width tillage looking at no P and K. So just in general to look at, how responsive were these sites were actually at. The next treatment being again with full width tillage, looking at spring broadcast P and K. So that's 60 pounds of P and 60 pounds of K was just broadcast across the field like a normal broadcast application. Then the third treatment was again still full width tillage, but we looked at moving half of that broadcast application to the planter to apply in a 2x2 planter starter band. So those are all of our full width treatments. The remainder of treatments we looked at were always strip till treatments. So we have one treatment where we fall shank applied the P and K fertilizer with the shank in the fall. And I'll get in a little bit more how we're actually doing that. The fifth treatment was looking at fall applications, but moving half of that fertilizer to the planter in the spring to look at the efficiency for moving fertilizer from that fall strip to a spring strip till application or a spring planter starter application. And then our sixth treatment was looking at coming in the springtime with that full amount of P and K fertilizer applied in the strip in the spring. The strip that we're using for the project is a Kuhn Krause Gladiator. There's just a close-up of what the row unit looks like. So it is a shank style strip tiller. There is a large slicing coulter out front that slices residue. You've got two notched disc type row cleaners that are pushing residue away from that the shank. And then we're going through with a shank, and then you've got two berming coulters at the back that are kind of building that berm, and you can adjust the aggressiveness or how much berm versus how flat you want that. And at the very back is just a rolling basket with chains to give you a bit of finishing action on that on the strip. From a fertilizer placement perspective, the one thing I like about the Kuhn Gladiator is it gives you the ability to adjust fertilizer delivery independent of shank depth. So if you look in the picture here, you can see the shank is still partially buried in the soil where we're making this strip. You can just see that stainless steel tube on the very back of that shank delivering fertilizer. So in this case here, we've got it set so it's about 4.5 inches deep. The idea being that we don't want to be down at the very bottom of the shank, which we're running at 6 inches, that you might hide too much of that fertilizer for a starter fertilizer effect. So we want to be somewhat close to where we're putting seed for, to get some of that starter effect. But we also don't want to be so shallow that we're putting that fertilizer, right directly in that seed zone where we could have some safety issues as well. So we've kind of settled on that 4.5 inch kind of mark in terms of separation from that fertilizer band compared to where we'll be planting, around 2 inches deep for
Hey,
our
Ben.
trials. Yep.
So I have some guys complaining to me that when they're running a shank tool and they have a fertilizer tube at the back, even when they try to shallow up that tube, that the fertilizer is hard to get to sit up in the berm. It tends to draft down behind that shank. Have you had any experience with that, or been able to keep that fertilizer from running to the bottom of the shank?
Yeah. So good comment, Greg. So in this one, I've actually been relatively pleasantly surprised, I guess, when we first started running things, how we did seem to be getting a band. So when we would go out and dig behind the strip tiller, almost like digging with a planter band behind a planter, we could find that concentrated band of fertilizer behind where that shank was. Now there's some differences in year two, which I'll get into a little bit later on. But at least visually looking at those strips, you did seem to be able to find a band of fertilizer. I don't know if it shows up really well in this picture, but you can kind of see just to the right-hand side of that tape measure, there's 4 or 5 fertilizer pellets. And when you did dig through, you could find where there was a bit of a concentrated zone where we were dumping things. So at least with this setup that I'm showing here right now, it didn't seem like everything was going right to the bottom, 6 inches
Yep,
down to the bottom of that shank.
fair enough.
And again, to touch on things, talking about a safe fertilizer rate perspective, when we're talking safe rates, we're usually adding our kind of salt fertilizers up. So that's N, K, and S all added up together. So when you look at the safe rates for 2x2 bands in a book, so if we're in the agronomy guide, recommendations are if you're using a urea blend, not to be more than 70 pounds per acre for a 2x2 band. If you're using a non-urea nitrogen source, you could maybe push things to 104 pounds per acre. So in this case here, I'm putting down 60 pounds of K and I'm putting down 30 pounds of N. So that's 90 of N plus K together. I'm not doing any sulfur in these trials, so there's no sulfur addition. So, 90 pounds is over the 70-pound suggestion for using urea-based blends. And when you look at separation between seed and where we're placing fertilizer, I'm only at maybe about 2 inches, maybe a little more than 2 inches in this scenario versus a 2x2 band, which if you're actually 2 inches over and 2 inches below your seed depth, that's actually about 2 3/4 inch of separation. So I'm a hair closer than what you'd be in a 2x2 band, and I'm pushing things a little more than a safe rate. So, not as a recommendation or anything like that, but just to put that forwards, that's how we are comparing in this project in regards to safe fertilizer rates for 2x2 bands. We really don't have well-established safe fertilizer rates for strip till, and I think it depends a lot on blends and where you're placing fertilizer in that strip, which can be quite different for different types of strip tillers. But at least to kind of show where we're running things and how that compares to a safe rate, that's kind of where we're at. So for the first general question, where our locations actually responsive to P and K? So we did go out and take soil samples ahead of time to make sure that we weren't, crazy high levels, and most of our fields came back, being quite responsive. So in a lot of cases, our soil test P levels were under 10, maybe 10 to 15 at the most, and our K levels were in a lot of cases, sub 100 for a lot of the sites that we were at and working on. So to look at this, we compare the treatments where we put in our conventional till scenario. So we had one conventional till where we didn't put any fertilizer on at all. That was kind of our true control, no fertility. And then we compared that to where we broadcast fertilizer in that scenario to see, in the general sense, where our sites responded to P and K. So on average, across the 10 site years we've got up to this point, the last 2 growing seasons, our average yield response was about 16 bushels an acre to broadcast fertilizer. So clearly, on average, we were responsive to fertilizer, which would give you some confidence that if we're looking for differences in yield for efficiency or for timing or placement, that hopefully those efficiencies or differences should show up because we are on quite responsive soils. Uh, it just gives an overview of the 10 site years we've got to date, and clearly shows that at large responses to fertilizer at most locations that we're at. So it checks that box that we are on site should respond to fertility. So the next question was, how does spring strip and shank placed P and K compare to spring broadcasted incorporate? So again, a question I've had presenting strip till data in the past, some other projects that have been involved with. And question growers have is strip till more efficient because we're putting fertilizer in that strip where we're going to plant corn into later on, either the next year or later on that spring? So again, to compare that, we looked at our broadcast scenarios under conventional tillage, where you're doing full width tillage and broadcasting that fertilizer across the whole soil profile. And then we compared that to our spring strips where we shank placed that same amount of fertilizer in that strip with the shank, kind of how I described earlier. And again, when you looked at the average across all locations, so all 10 sites we've done to date, there was a significant response to that shank placed strip fertilizer over broadcast fertilizer with full width tillage. So on average, we were about 7 bushels an acre higher for that shank placed fertilizer in the strip in the spring. Again, when you look at summary across locations, things are somewhat variable. We had a number of locations where that spring shank application was significantly higher than where we broadcast fertilizer, but there was also a number of locations where there wasn't much yield difference between those two methods. So, of course, when you were a little bit confounded comparing those, I can't tell you whether it was completely the fertilizer effect of having fertilizer in that strip, or if there was an advantage to the strip till tillage compared to the conventional width tillage that we were doing with conventional. So, but when you compare those two systems, we did seem to have an advantage for the strip fertility over broadcast on low fertility soils.
And Ben, this was always the 60 pounds of P, 60 pounds of K, either broadcast completely or put through the strip tiller in the spring.
That's right. Yep. And I think
Hey,
somebody.
Mike, sorry, go ahead. I just wondered, Mike, chime in there on broadcast versus strip till fertilizer. What's like Ben's showing a 7 bushel advantage overall. for putting the P and K in the strip versus broadcasting it. Where does that fit in your operation if you think about broadcasting versus strip till?
Yeah, we see maybe a little bit, but I would say Ben's response is bigger than what we see in broadcast versus fertilizer in the strip, I would say. But yeah, like 6.7, that's a pretty big response, comparable
Yeah.
like the spring fertilizer. So
You've got your corn sold at $7 this year, so 7 times 7, that's a $50 advantage for strip till placement of the fertilizer.
no
Anyway,
And again,
yeah,
I
problem
think,
all
cool.
day.
Yeah. Go ahead, Ben.
yeah, sorry, I was just going to mention, again, we are on the conservative side. Somebody could push and say, well, I'm applying more than that ahead of my corn crop, so maybe we're shorting things a bit from that perspective. But again, to try to at least test those systems and see if there's an efficiency, certainly that we saw more efficiency when you're putting a modest amount of P and K, moving it from broadcast to in the strip.
Yeah.
So going back to our third question, if you're on ground that allows you to strip and apply P and K in either the spring or the fall, is there an enhanced yield for the spring strip and P and K? So sometimes that question comes up when you're on low fertility ground. Is it more efficient to put that fertilizer right ahead of the crop, or can you put it on the year before, or are you going to have issues in terms of fertilizer response, especially when you're on low fertility ground? And again, the question on, does my ground allow me to strip and apply in the spring or fall? So, these trials that we were on, we were in Wellington, Oxford, Perth, Dufferin counties. Most of the soils we were on were, medium loam, silt loam to sand loam soils. Maybe the heaviest we were on was a Perth clay loam at the Perth demo farm just north of Mitchell. But for the most part, most of these fields we were on, we didn't have an issue coming in the spring and making a good seed bed. So, this might not apply to all growers, but if you're on ground, you're not afraid to strip in the spring. These are the comparisons that we made on ground where we could make good strips in the spring. So overall, comparing all the fertility in the strip in the fall compared to everything with a spring pass, we had a 5 bushel yield advantage for the spring strip fertility compared to fall strip fertility. Again, just a quick shot across the different sites. This was somewhat variable. We had one location where there was a really strong response when you're just looking at the stats within location, but certainly a general trend for some yield advantage for spring strip and fertility compared to a fall strip and fertility on soils where you can comfortably do both. Yeah, so just a bit of a comparison across those locations where we've done that.
Yeah, this is like we did a lot of these plots, and that's definitely something we did not see on our 3 years of data at multiple locations.
So no,
You did not, Mike? Yeah, go ahead, Ben.
We did not see any fertilizer benefit having the spring versus the fall when we did our plots. We looked at 2 different ways, just spring strip tilling, or when we did the 2-pass system, we looked at doing it all in the fall, or doing 50% in the fall and 50% in the spring. When we did the spring pass, like the 2-pass system, we didn't see any benefit having any in the spring. So,
what kind of
would
rates
you
would you guys
generally?
put in
Yeah, I
the
was just
fall?
going to say, would you generally have higher testing soils, maybe, than the? Well, I don't know. Maybe we should go back and Ben. This is not a fair question, but can you tell us sort of what your average soil test P or soil test K is across these sites?
Yeah,
I
so if
mean,
I had to
I
say,
know you've told us they're kind of responsive.
yeah. So I would say an average we're probably sub 10 for P, and K I'd have to look back, but certainly we range from as low as 50 or 60 at some sites up to maybe 80, 90 to 100 at maybe the most. Maybe there's some a little above that, but those are the kind of ranges that we're talking anyways.
Yeah, cool. So, Mike, maybe you'd like to comment on that. You probably wouldn't be running on soils that were in that range at all.
no, not at all. If anything, we're right where they should be, or even maybe a hair higher. So.
Yeah. So, yeah, cool.
And again, that was a bit of the challenge with the treatments. If I'd had some blank fall and blank spring strips, we could have teased out whether it was purely a fertility thing or a tillage thing that was getting that. But yeah, I didn't. You only have so many treatments you can fit in a site, so. But that maybe would have given us some more answers. But yeah, if I had to guessing what Mike said and some of the other things we played around with, it does make it think if it's a fertility fertility response that's really driving that, maybe more so than necessarily a spring versus fall thing. But I don't have the treatments to definitively say that. Oh yeah, one thing I did want to mention on this as well is that these spring fertility treatments that we did, especially in 2020, when you went out to the sites, or sorry, 2019, when you went out to most of the sites and looked across the field, there was one treatment that always jumped out at you. The corn was bigger, greener, more consistent looking than the rest of the treatments, whether that was the on-farm trials or some of our small plot sites that we did as well. And consistently at all the sites we were at, it was that spring strip fertility treatment that was jumping out compared to the rest of them. So I don't know if it shows up really well in this picture, but this is a video that we had done with Real Ag. And on my left-hand side, so the right-hand side of the picture is the spring strip fertility. And then on my right-hand side, which is the left-hand side of the picture, was the fall strip and fertility. So really visual differences in 2019 between those two treatments. Now it didn't jump out quite as much in 2020. You can see the yield responses maybe not quite as strong in 2020 either. But I did have to make a bit of a difference to the strip tiller setup. When we were first running the strip tiller, we had two hoses coming off our outlets on the dry fertilizer box. They would come down to a Y, which would go down to the fertilizer tube that I showed earlier. But I was having trouble with that Y and getting fertilizer down to all the outlets. So I think the Y was constricting things too much, and I was having issues with some of those outlets starting to plug. So we would get fertilizer running out the meters because those hoses would start to plug. So I did change setup a little bit in 2020 because we weren't able to run those Ys. So again, there's the what our strip tiller setup would have looked like in 2019, aiming for maybe 4.5 inches deep fertilizer placement with the Y coming down, putting two hoses to one outlet. I wasn't able to do that without plugging issue, so I had to build another tube on the back of that shank, or on the back of that fertilizer delivery tube, so I could have two hoses running down without using a Y. So this allowed me to place both those hoses in that trench. I put that piggyback tube right at the same depth as the front one was at. But one thing I seem to notice is that when I put that second piggyback tube on and then went out and did some digging, it seemed like in that case I was getting more fertilizer going down to the bottom of the trench than what I had seen when I was running just the one outlet. So I am wondering a little bit, Greg, like you had mentioned before, that I think when I put the piggyback tube on, that it was maybe stopping soil from coming back and holding that fertilizer in that zone. And I'm kind of wondering if that same thing affected our responses at the spring fertility treatment. Because again, in 2019, you could easily go to site and see that spring fertility treatment jump out at you. But in 2020, I didn't see that at any of my locations like we did in 2019. Maybe it was a year thing as well, but I am wondering if this fertilizer setup was maybe resulting in some more fertilizer going down to the trench, or maybe not getting us as concentrated band as what we had without that piggyback tube.
Cutting torch to take that piggyback tube and shorten it up a little bit maybe would allow it to sit up in the zone a bit better.
Yeah, and I didn't, again, it was kind of a last minute thing. If in the perfect world, I would have made it adjustable so we could maybe pick it up a little bit more, but I do plan to do some treatments this spring to compare with that piggyback tube versus without it, to see if that was driving differences in response between those 2 years. So last question, or number 4, is there, getting to the big question of this webinar, is there a yield response for moving a portion of fall strip P&K or fertilizer going down in the strip to a planter starter in the spring? So again, in this one, I only compared that for our fall tillage treatment. I didn't do the comparison for the spring ones, just to, again, preface that a little bit. But when in this case, we moved half the fertilizer from that fall strip till application to the planter in the springtime in a 2x2 band. And when we looked at that for our treatments, on average, comparing those, we had a 1 point, just under 2 bushels an acre response for moving half of that fertilizer from the fall strip to the spring planter. When you looked across locations, there's a bit of noise, pluses and minuses, but we didn't get any significant responses at any of the locations. You can maybe say there's a tendency for a slight positive response, but no significant yield response across all the locations. and numerically, a 1 or 2 bushel response for moving half of that fertilizer from the fall strip to the planter in the spring. I guess that's where I'm curious, Greg, how
Yeah.
this lines up with stuff you've played around with, and then Mike as well with your on-farm work.
Well, I guess the part that maybe puzzles me a little bit, Ben, is if you seem to get pretty significant advantages to spring strip till fertilizer, right? You would have thought that if you got an advantage with spring strip till placement, that you would have seen some of that advantage flow towards you if you were putting it on the planter, right? As a
Yep.
as a starter on the planter, right? The you would have thought that the tendency for those sites, if they responded better to spring strip till fertilizer, they would have also responded to having a bit on the planter instead. So that's I guess my only observation. This goes back a little bit maybe to Mike's comment about, did it matter much whether the fertilizer was in the fall strip or on the planter? I think you've done some of that work, Mike.
Yeah, no, we have, and almost did the exact same plot a couple of years ago. We took 50% of it off the strip tiller in the fall, and we came in with the planter and replaced the other 50% with the planter. Yeah, we seen a lot bigger response. We seen like 7 bushels, and it was almost, we did 4 reps, and it was almost identical. It was 100 acres we did, so they're big reps. And yeah, like that was not the response I was hoping, because I was hoping for a bigger planter. So we are going to keep doing those plots again this year. We're changing a little way we're doing it. We're going to look at see if we can make that response bigger by putting a little bit extra fertilizer on with the planter to get a little bit bigger starter effect. But yeah, this data definitely surprises me. I agree with Greg. Like I would thought in a moment, you're seeing with the strip tiller in the spring, you see with the planter, because if anything, the planter is placing it more perfectly with the seed placement versus a planter. And I know a lot of the data of the states would argue better with a planter place just because of the root growth of the corn plant versus strip tiller puts a fertilizer right underneath the seed, where supposedly corn doesn't like that as much, right?
Mike, do you have a comment about, so this is really getting right to the crux of our question here, but do you have an opinion based on your experience, whether if you're fall stripping with fertilizer versus spring stripping with fertilizer, out of those two options, which gives you the better chance of running fertilizer free on the planter?
Yeah, from our 5 years of data and many plots, it didn't actually make a difference if you put in the fall and the
Really?
spring. No, and we looked at different placements. We had one strip tiller at one point that it would band it and mix it, or do both. We looked both at fall and spring, playing around those different placements. Yeah, it really didn't make any adjustment. Like right now, we talking about fertilizer placement with we have a shank unit, and we're trying to mix our fertilizer more. So our fertilizer pipe is no tube in the ground, it's right above the surface. We have it, I think, 3 inches back from the shank. See, about 50% of the fertilizer falls to the bottom of the strip. The other 50% gets pretty evenly mixed the rest of the way. So about 50% of it's 6 inches deep. The other 50% gets mixed from top to bottom. So we've been playing around with fertilizer placement. We find mixing is just as good as anything else. So that's kind of where we went with that. And when it comes to fall and spring, we really thought when we were doing this refreshment pass that was going to give us a starter effect, but at the end of the day, there wasn't really much to it. Maybe a bushel, but statistically that wasn't nothing. You can't worry about it too much. So we kind of got to the point, if your ground is capable of strip tilling in the spring, it doesn't hurt. If your ground isn't, don't worry about it. Doing the fall and put the fertilizer down still. So
Yeah, and again, that might be a function, and this, I'll go your way on this one, Ben. That might be a function of whether your fields are pretty well built up already versus fields that are very needy for starter fertilizer, right? It
Yeah,
might change a little bit depending on how responsive your soils are.
yeah, and I was kind of wondering that too. So again, in the spring strip, we are putting that full amount in the spring right by the seed. Compared to this, it's 50% going in the spring. The other thing is, if I had one complaint about this research project, is that the planter we're using, if I had an adjustment I could make to it and I had the funds to do it, I would change to boot style fertilizer openers. Right now it's a John Deere 7200, and we've got the tubes going down behind the single disc opener, but fertilizer placement of those tubes I find isn't perfect, even when you try to fiddle around and adjust them as much as you can. I'd be curious if we would have been any different if we had, a nice set of boots on those fertilizer openers too, if that would have changed this
Yeah,
response.
fair enough.
The last one before we get back into that question again is, in general, what was yield performance of strip till compared to full width tillage? Well, I didn't really have the exact perfect comparisons to make, or we had the same fertility placements or options, so it's a bit confounding to compare all of them. But, generally speaking, when you compare our full width, and I say full width more so than conventional till, because depending on the location, springtime tillage was always black and bare dirt to plant into, but some locations had fall tillage, some didn't. So depending on where we were, but I'll say full width tillage. Certainly our yields for the strip till systems were as competitive with the full width ones, some cases higher, which I think, again, without the treatments to know for sure, but I would speculate was probably strongly driven by the fertility placement options in the strip till. But certainly I don't think we had much evidence of yield drags at our sites for strip till compared to the full width tillage that we were doing at these locations. Oh, kind of expanding a little bit more again on this kind of main question of the webinar: is there response for moving fertilizer to starter fertilizer application when you're already putting fertilizer down in the strips? Again, this was some data I had from this project we're working on right now. I've been able to scrounge a bunch of other data together from past research through OMAFR and some soil and crop stuff, as well as a number of on-farm cooperators who have worked on this question as well. So in total, we've got 28 different comparisons that I've been able to pull together to try to answer: is there a yield response for starter fertilizer on an already fertilized strip? And if you average all 28 of those trials up together, there was a 4 bushel response for starter fertilizer on a starter fertilized strip. But I thought I would break things out a little bit because all the trials were done just a little bit differently. There's a lot of different factors for these different trials, so I've tried to put those out as easy as you can look at. The green bars represent trials where it was a spring strip and fertility system. The brown bars represent where it was a fall strip and fertility system. So if you see the two, that's the difference there. I also tried to compare the different methods that fertilizer was going down. So if you see a little B at the end of a column, that just means that was a trial where fertilizer had been shanked and banded. If you see if there's no label at all, it just means it was usually a coulter and mixing system, or mixing with the shanked type system as well. So this is a summary. Out of that 28 summary data set, we had 3 trials where they were adding dry fertilizer on top of fertilized strips. So again, we weren't looking at the same amount of fertilizer between the two, so it maybe isn't the fairest comparison to make from strictly an efficiency perspective, because it's maybe looking at response to fertilizer too. But when we summarize those 3 trials where they were adding dry starter fertilizer to an already starter fertilized strip, on average, the yield response to those 3 trials there was 0 bushels an acre. But again, there was variability. There was a couple trials where there was negative yield responses, and one trial where it was a positive yield response. I haven't run stats on this data yet, but when you look at those sites, the ones where we did have negative responses, those were trials where we were on fairly light, sandy type soils, where maybe that extra starter fertilizer, if it's not just background variability, maybe too much was going down in that strip from a safety perspective, or maybe there was issues going on there. But averaging those 3 trials where we added more dry fertilizer to a dry fertilized strip, no response in those 3 trials that we have anyways. Again, the same question was asked: if we've already got a fertilized strip and we're coming back with a liquid system, again, just adding liquid to a fertilized strip, what was the response in those cases? So in this case here, this is almost all spring strip till, except the very middle one where it was no response as a fall strip, and then coming back with liquid fertilizer on the planter. So in this case, on average, there's a 10 bushel an acre yield response when you're putting liquid on top of an already fertilized strip at these locations. Again, a lot of cases where it was lower fertility ground, not all cases, but in several cases. but some fairly large yield responses at some of these sites, including 2 trials that were done in 2020 as well. Especially one of them, that very last one, being on lower fertility soils as well. So it did seem like there was. I haven't worked soil tests into here to really look at, was soil test a factor that, some sites didn't respond and some sites did respond. But certainly there were some sites that still had strong responses adding liquid to a fertilized strip.
Now, Ben, these are all green bars, so that's assuming that these were all spring strips where the fertility was incorporated into the spring strip tillage operation, right?
That's right. Yep.
And then the height of your green bar is how much additional yield you got by running a liquid fertilizer on the planter, even though you'd already done spring strips with fertilizer incorporated.
That's right. Yep.
10 bushel average. But
At
sort of
these sites.
dominated by those 2 sites that went through the top there, right?
That's right. Yeah. So I think those 2, like you said, really drove what that response was, the 10 bushels.
Yeah. Hey, Mike, so what's your answer to that question there? Spring strip till with fertility down in the spring, do you still need to bring liquid in furrow on the planter?
We're seeing about 7 bushels for about the 4 of the 5 first years we were doing the liquid pop-up on the planter. But now I would say I don't know what we all changed, but the last 3 years we haven't really seen any response at all.
Okay. Now, was
So I'm
that a
not sure really
function
what
of,
we changed, but we do the plots
yeah,
every year. So
is that a function of your improvement in the fertilizer mixing into the spring zone, or has that changed over those different trials?
yeah, so the first year, actually it'd be interesting. The first years we did the plots, a lot of the fertilizer was going down in the spring. The last couple of years, all the fertilizer is going down in the fall. So that would be the biggest thing that changed over the last 7 years of these plots is actually more of the fertilizers going in the fall, and we're seeing a less of an effect of the liquid pop-up. So
Okay, that's a head scratcher for me then.
yeah,
Because
it is for us too. That's why we keep trying it. So
yeah, fair enough. Yeah, cool, good, thanks.
Well, kind of the last set of comparisons we had is, locations where we kept the amount of fertilizer the same to see if, is there a yield response and you're just moving fertilizer. So, now we're balanced in terms of the 2 treatments. So we're not sure if it's just responding to more fertilizer. Just moving fertilizer from the strip tiller to the planter, in this case, all dry systems. Is there a yield response for making that fertilizer movement? So in this case here, I think we had 18 trials in total where fertilizer was moved from either a fall or spring dry strip till application. A portion of that was moved to the planter in the springtime. And again, on average, we saw a 1 bushel yield response from moving fertilizer from the strip tiller to the planter. Combination of spring and fall sites. It's kind of hard to say looking at that data if one really drives you more than the other in terms of response or no response to moving that fertilizer. Certainly there were some locations that had some larger responses, but some where they were less as well. But on average, a 1 bushel response when you keep the total amount of fertilizer the same, but just move a portion from the strip tiller to the planter. I don't know, Greg, if you have any more comments on that or the comparison of those planter versus strip tiller comparisons.
Yeah, that's good stuff. I mean, that's clearly, I think, one of the key questions. And I'm obviously interested to hear. I think Mike has sort of alluded to this, but if I had invested heavily in a strip till system, I would like to think that I could get the fertilizer off the planter because I've done such a good job of putting the fertilizer into the strip. I don't know, Mike, whether you want to wade in on that.
yeah, no, I think that's most people's end goal is make the planter more efficient in the spring, especially with us being a fall strip. We just want to get the workload out of the way, and we've been playing a lot around with what fertilizer rates, making sure we get farm levels higher, because I think even just general data shows like if your farms are sitting at better rates of fertilizer, again, we don't rent much land. If your yeah, if your land has better rates, you're going to see less of a response. And we're trying to place that fertilizer. Like one of our big plots is this year, we took half of our strip tiller and we have 2 different setups on placement. So we're going to know better next year if that mixing tube action is going to work better. And we're hopeful it is, to get a little bit better starter effect, let's call it, from that dry fertilizer. And again, every year we're using liquid pop-up to see if we need it or not. Some years you feel like you're winning a little bit, the next year you're losing a little bit. So at some point we're gonna have to call it. But I think we have 7 years of data. So, and like I said, the last couple of years we're not seeing the same response as we've seen the first 5 years. The first 5 years was pretty consistent, 7 bushels an acre, and the last couple of years it's honestly been 0. So
Yeah, interesting. Yeah, so I think that's exciting in terms of trying to narrow in. And is it a soil test thing? You've made that comment there, Ben. You know, do you when you move away from lower testing soils, does the does the are the odds of being needing, or is there a real advantage to having starter on the planter? You would think the answer to that would be yes, but I guess we almost have to look at some of this data under the lens of where the soil tests were.
Yeah, I think so. And one thing to look at, again, I think, when growers ask this question, one thing I'm curious too is the fertilizer placement in the strip. And Greg, you did a bunch of that work back in the early to mid 2000s. That, I think if you're putting a lot of fertilizer in the strip, but it's going right to the bottom of that trench, you're probably not getting much starter effect, and that's where your probability is going to increase a lot too, I would assume.
Yeah, you in the strip till system, you're really trying to replace both the in-furrow fertilizer and the 2x2. That would be the goal. You want to replace both of those placements, in-furrow and 2x2. And to do that, you've got to have that fertilizer well mixed into the zone without causing a burn issue, right?
And that's one thing I was going to just mention really quick. So again, this is some work we've done in the past. This was trying to push nitrogen rates in a spring strip till trial, a trial that you had started, Greg, when you were at the ministry. And the first year didn't work too bad. Obviously, you push things too much, we had issues. But the second year, we had put some dry fertilizer banding tubes on. I think with the premise that you would band fertilizer in the bottom corner of the trench, which sounds like a good idea. But in this trial, it was kind of leaving it right at seed level and was causing some big issues. So maybe attractive to have things higher from a starter fertilizer perspective, but obviously if you're trying to push things from a safety perspective in a blend, lots of risk if you're leaving shallow bands in some of these soils as well.
Right. Hey, I only made 607 mistakes during my OMAFR career, so there's just one more of them.
And then I guess, again, the other thought, and we just talked about this too, was obviously where you're putting fertilizer from a depth perspective in that strip. But the one thing, and Mike kind of alluded to this with his trying to change the setup on his fertilizer, can you get a system where you get some fertilizer going down lower in the strip from a safety perspective? It also gets some mixing up higher to get some of your starter effect. And that is one thing that I kind of thought about, with these 2 tubes, could you play around with different blends or just splitting a blend where you're putting, from a safety perspective, one chunk in the bottom if you're trying to really push things, or maybe more nitrogen of a blend in the bottom, and then still leave one portion of it up shallower where you could still get some starter fertilizer effect from that, still mounted on your strip tiller, not on your planter. Something to be kind of fun to play around and see if there's some options from a different placement perspectives in a strip instead of just one placement or just blending in that strip. But that's all I've got from the research and project perspective and collecting results. Before we finish up, I just wanted to give acknowledgements to Grain Farmers of Ontario and Canadian Agriculture Partnership, who have funded the research project, as well as Stoltz Sales and Kuhn, who have provided us with the strip tiller, as well as Premier Equipment and John Deere Canada, who have provided us with tractors. And big thanks to all the farm cooperators who have helped out both with that big strip till project, as well as all the on-farm strip versus starter trials we've done, and a couple of summer students who've helped me over the years as well. That's it on my end of things from the presentation side. Greg, I wasn't sure if you had anything more else to add to the conversation in terms of starter and strip placement.
No, that's been excellent. I thank you both, and we'll move on to some questions now. Good. Hey, thanks. We've got a bunch of questions flowing in here now. Let's start with the soil type questions. Ben, the question came in from someone on heavier ground. Is the soil type clay or loam in most of your trials? And would the fact, if you were more on clay soils, would the fertilizer run into the bottom of the shank opening be more of a problem?
Hear me?
That's good there now.
Okay, perfect. Yeah, so we were mostly on, I would say, medium to light textured soils. Predominantly loam, sandy soils is what we were on for this project. That's a good question. I don't have a really good answer. We didn't get around playing on clays nearly as much from that perspective. Yeah, I could only speculate on that, and just haven't got on the heavier soil textures with the strip tiller.
Sure. Hey, Mike, you're on some heavier ground. Do you find it's more of a challenge on the heavier ground to keep the soil up in the zone, or what's your experience there?
Yeah, when it comes to fertilizer, yeah, I would say a little bit. Like I know with ours, when we were trying to keep the fertilizer more mixed, we had to put it about 3 inches back from the shank, so that give the soil a little bit more time to close
Oh yeah,
behind the shank. So it also affects speed of the machine too. The faster you drive, probably longer that opening is to say, give less time.
right. Yeah, no, good point. I think we heard that during the session, but I think that was good to re-emphasize it, that it's not just vertical placement of that fertilizer tube, but where you position it relative to the soil closing in around it allows you to keep the soil up in the zone a bit more, right?
Yeah, that's for sure. Because yeah, it's all different. Like clay definitely stays open a little bit longer. You get in real wet conditions, I don't think it matters what you do, it's going to fall to the bottom because it's
Yeah.
open just sometimes, right? So
Yeah, cool. So Josh chimed in here on the session and talked that Kuhn does manufacture a dual tube fertilizer placement setup. I don't know whether have you seen that, Ben, that there is a dual tube setup according to Josh?
No, that's new to me. That's interesting to hear.
Right on. So Lloyd, I think looked at your picture versus and the picture where you consistently saw in 2019 the advantage of the spring strips with fertilizer compared to the fall strips with fertilizer. And his question is, are you sure was that the same fertilizer going in both fall versus spring and the same relative positioning? Just comment, I guess, on the fall versus spring, where it looked like the spring was so much more advantageous early on.
Yeah, so same fertilizer setup on the strip tiller. We put the same blends down. Even nitrogen should have been the same because in both of those treatments, it would have been 30 pounds of N 2x2 band. So yeah, essentially, other than timing, everything else should have been the same between those two treatments.
Very good. And then I guess you go back to, I guess, this predominant question that's sort of an underlying our discussion is one of the key differences here, whether you're on very responsive soils or whether you're on soils that have been quite well built and maintained, right? I think there's an underlying theme here, and a few people are asking about it. Is the response to the spring strips really driven by low testing soils, and that if you're on a ground that Mike is managing, where soil test levels are quite elevated, you're more of a build and maintain sort of guy, that maybe whether you're fall versus spring, or maybe even whether you're planter versus strip tiller, that it's much more important on starter placement on those low testing soils. So I know we've touched on that, but a bunch of the people that are watching today are commenting on that. Maybe we just revisit that one more time, Ben, in terms of your experience.
Yeah, so again, we haven't done any up to this point on higher testing ground, but if I had to speculate looking at the treatment responses we're getting, and I don't have the perfect comparison, but if I had to speculate, I think fertility is really driving the responses that I'm seeing in some cases, maybe more so than a tillage or tillage timing effect. I put some more treatments out in some of the locations where we've got room to put more in to try to answer that a little bit better. But right now, if I had to speculate, I think it's really a fertility effect that's really driving some of the responses that we see.
And just on that comment, Ben, one of the visitors this morning is asking about your 2019 response to versus 2020. Any comments on what was driving that? Why the bigger response to moving the fertilizer to the planter in 2019 instead of 2020?
Yeah, so I guess I'm not sure about moving to the planter as much, but certainly from the spring strip till perspective, one of my thoughts is that changing that banding setup a little bit. And I'm thinking again from visually and doing some digging, it seemed like I was getting more fertilizer lower in the trench with that double band setup.
I got you.
On the strip till side of things, I'm thinking setup must have had an impact because certainly, I mean, you could say it was location too. We weren't at the exact same location, same farmers and that sort of thing. But the fact that I saw that response at almost all the locations, whereas in 2020, I didn't see that strong response visually at any of the locations. So I'm really thinking it was a setup on the strip tiller that maybe impacted things.
Yeah, so that's a good reminder. The 2019 was the double band that may have ran more fertilizer to the bottom of the trench.
2020
Or
would have been the
20,
double band.
yeah, 2020, more fertilizer to the bottom of the trench. Yeah.
That's what I'm thinking. Whereas 19, I'm pretty sure I was getting more of a band close, higher up.
Yeah. So this is a question for both of you. The idea of doing spring strip till, does it impact uniformity of the seed bed, air pockets, performance of the planter? Maybe you could both comment on whether the planter performs from a, not from a fertilizer perspective, but just from a physical planting perspective. Does the spring strip till open you up to any more problems compared to, well, either fall strips or conventional cultivated ground? Maybe
Yeah, so in
Mike,
our
you can, or
trials,
Ben, go ahead, Ben.
in our trials again on the medium to light textured soils, we were able to make pretty nice strips either in the fall or in the spring with the Kuhn Gladiator that we're using. I don't think anybody would have complained either fall, like stale seed beds in the springtime, or the spring strips we were making. Maybe toughest ones we made were the ones we made at Perth Demo Farm on the soil map. That whole area of the county's Perth clay loam. Again, still didn't make a terrible job, but it was a little chunkier than we had at other sites. But I think still, once we came back and planted the next day on those strips, I don't think you would have complained from a plantability perspective on those spring strips.
Right.
Yeah, no,
Mike?
I think it all comes down to soil. If it's sandy loam, sand, good loam, spring or fall doesn't matter. If you start down the heavier side, I would definitely trend to the fall strips. At least that's what we find. Because sometimes those heavier clays, they can not be the most pretty bed, or at least when you do them in the fall, they look pretty good as a stale seed bed. But when we get our plots in the spring, we always do them on more sandier soils. They can look pretty good if it's a raised soil type. So I think it really comes down to soil type, because you talk to farmers that have shank strip tillers and they're going deep, but it's a nice sandy loam, they get away with it. But I know if you did it on some of this heavy Wofford clay here where I'm at right now, would not want to do that at all. You would have no luck at all. So, but on our sandier farms, you can get away with it.
Right. So we've mentioned liquid fertilizer a few times during the presentation this morning. I'm assuming that for the most part, Ben, whenever you talk about your liquid on planter, you're always talking about an in-furrow liquid system, right? When you make comparisons of liquid on planter, is it all in furrow at 4 to 5 gallons is your guess?
Yeah, essentially that would represent what all those liquid responses are for the most part.
Yep. And Mike, do you run any you don't run any liquid, but what's in furrow, right?
Yeah, only in furrow, the same thing, 5 gallons an acre.
Yep. And so there was a question then, Ben, the negative response to liquid starter seemed odd. Any comments on that?
Yeah, so again, I could only really speculate on that. It could just be random variability that you get some negative yield responses. Maybe the fertilizer wasn't giving anything, but there's random variability in the field. Those strips are a little bit lower yielding. The other cases, again, some of the sites where we've got data was on fairly light sand. So You know, if we did that on a drier year, maybe there was a bit of burn or some other risk going on in that. But yeah, up to absolutely say what was going on there.
Yeah, fair enough. So Jeff has a question. If you're worried about the fertilizer running too deep, why run the shank so deep?
Yeah, so we're actually on the lowest setting you can with the Coon, so we can't go any shallower than what we're at right now. But yeah, of course, that's one thing to look at. Again, we've got play with the fertilizer delivery on that shank, so I think there's some things we could play around with to try to get shallower fertilizer placement too, but something we haven't done much more on yet.
Yeah.
I also find 6 inches is a sweet spot to build that nice berm, right? If you're much shallower than that, sometimes you don't get enough soil movement to really build a strip. So 6 inches seems like the sweet spot for shallowness. I know some guys run deeper, but I think 6 inches to build a nice strip is kind of that shallow point where you want to be. Most people run at 6 inches.
Yeah, I appreciate that. That's good comments. So one clarification on your results to date, Mike. You mentioned a 7 bushel advantage to having liquid on the planter in the furrow during some of your trials. Just clarify a little bit for the group. I know you said there was or has been evidences of that 7 bushel advantage, but just where do you sit today in terms of advantages to having starter on the planter?
Yeah, so our first 5 years of data, so that would have been, work back 7 years now. It was 7 bushels. There would be a little uptick or down, but the first 5 years was 7 bushels over the 5 years. Probably now, if you add the last 3 years in, because the last 3 years were 0 response or even a little bit negative response, we're probably getting down more that at 4.5 bushels if you look at the 7-year average. So honestly, the last 3 years, we haven't seen a response at all. And we had 1 year that it was a negative response on every rep, just that 1 year. I think last year we seen about a 1 bushel response, but yeah, it's been very interesting how consistent it was and now how that changed quite quickly.
So Ryan chimes in on that point, Mike. Is this a function of you building your soil test levels up in those zones that's eliminating, or it looks like it's reducing the starter fertilizer impact? Any comments on that from Ryan?
Yeah, it might be a little bit. If you look at our soil tests as an average, they haven't changed much over the last 7 years, but we've been verbal rating fertilizer for 7 years now. So maybe like some of the spots in your farm where you're actually, if you do your samples, you're like very low levels, they're not as low anymore, right? And we're trying to deplete some of those higher level areas. So not the farm is consistent, but it's getting more better levels of like your P and K everywhere, I would say. The other thing too, and like I talked about, is we're working on better placements of the fertilizer, hopefully to help get a little better starter effect. Like we're trying to get some fertilizer, like just like basically at the surface and mixed all the way through, just so the plant always has a little bit of fertilizer there. And we're putting higher levels of fertilizer in our strip too. Like we're anywhere from, I would say, minimum 100 pounds of MAP potash mix up to 700 pounds.
Right. Yeah. So some good comments there. Thanks. Hey, again, a question for you, Mike. What's the biggest watch out or the biggest concern when you're trying to do a perfect job of planting onto strips? Do you prefer planting onto fall strips versus spring strips? Does it matter? And what's the biggest watch out in terms of getting your planter to run perfectly on strips of any kind?
I think planting on a stale seed bed, so a fall strip and stale in the spring, is probably the nicest thing to plant. It's a very mellow strip. Um, that we like that the best. It's like very loose and everything, like you don't have any air holes or everything's just nice. So when you try and do a stale seed bed, it's not the most important how chunky or not chunky it's in the fall, but you want like definitely a consistent seed bed. Even when it comes to spring, right? You don't want holes and valleys. And we've seen that with some of our old strip tillers where new ones have so many coulters to keep the dirt in, it doesn't leave the strip. So that's probably the biggest thing is make sure you have a nice smooth strip. Obviously, if you're doing spring strip, you want a nice powdery looking finished seed bed, which I think from Ben's pictures, the Coon was doing a nice job on his in the spring and fall. And for us, it's the same thing. It could be a little chunkier in the fall, but it has to be consistent. I think the biggest thing to make sure you're on this center is measure every row unit, both strip till and planter, make sure they're exactly on 30-inch centers or whatever spacing you are, because 1-inch spacing, you'd be fighting that all year. So that's something we do every year. Like, it's funny how things just wiggle around a tiny bit over the year. So every year we remeasure every row unit to make sure exactly 30 inches and make sure exactly centered on the bar. So that's probably the biggest thing we found for staying on the strips. I find the planter that sits on it pretty good. You get very familiar with the nudge button on your GPS, that's for sure. We're RTK everything, we're slowly nudging all the time. So.
Yeah, some nice comments there. Thanks. Hey, we're 11 o'clock Eastern time here, so we're just going to pause for a second. We would like to thank all of you who joined us today. We're at 11 o'clock. If you need to jump off, that would of course be great, and we look forward to seeing you next week. We've got quite a pile of questions still here. I'm going to ask you, Ben and Mike, just to hang with us a little bit, and we'll try to get through a few more of these questions. But if you've been with us for the last hour and you need to move on, we thank you for being here. So let's talk a little bit about, there's a question / comment from Kyle, generally asking you what was the product that you were using in your pop-up trials, and would it be better to make more sense to just increase the rate of MAP in your dry blend? So that's a little bit of what we've been kicking around here, but just comment on what you're using in your liquids, and then Kyle's question / comment: would it make more sense to just increase the rate of MAP in the dry fert blend? Go ahead, Ben.
Yeah, so I think the vast majority of those trials was 624-6 in furrow on the planter treatments. I guess coming back to the dry question, again, I think it depends on what kind of mixing. Like, if it's going in a spot where the plant's not going to get it early on, just backing rates up more in a spot where it can't get it might not help you. But if you're mixing in the whole strip or it's getting something shallower up, maybe there's some benefit there that would offset the need for in furrow. But I think it would depend on kind of where it's going in that strip if you're going to increase things to overcome that liquid in furrow benefit.
Right. Mike, what are you using?
The first year I think was 1034.0, then we switched to 927, and now we're 624.6 with some zinc. So majority of the year's been 624.6 with some zinc in it. So.
Fair enough. A question from Gary that I think needs to go your way, Mike. So on heavy soils, doing the fall strip, putting down all your P and K in the fall, or what percentage of your P and K on a heavy soil where you're not going to strip it in the spring? On a heavy soil, are you going to put all your P and K down in the fall in that strip, or are you still going to run some broadcast operations? Where's that fit on a heavy soil?
Depends on soil level. So on a heavy farm, if the soil levels are good and we think we get enough in there for basically all 3 years, we'll run it all through the strip. We got some farms we picked up over the years and they're a little bit more depleted. So we put in about 700 pounds an acre through the strip tiller. Before beans, we'll broadcast a little bit more, and then we try to pound a bunch in furrow with the wheat. So it depends on the farm and the levels where it goes.
Right. But
I might put more in the strips, but my cart can only do up to 700 pounds an acre. So that's kind of my limiting factor. So.
Right. But on a decent percentage of your acres, if I can say that, you can bring essentially all of the P and K you need and put it through the strip tiller, unless it's a farm that's got depressed levels, right?
Yeah, that's correct.
Cool. This is a question for both of you, and maybe a little more applicable to Mike because of being able to track it year after year. But do you see strip fertility bands in the following year's crops, or how does that work out? Do you see evidence of putting the P and K in a strip when you come back the next year, and do you put the soybeans back on the same band? That sort of question from Stephen.
Yeah, so we do move our strips. We don't worry about putting them every 3 years or 2 years back in the exact same spot. So we don't get that. I know some people like doing that. I think our fertility levels are like good enough overall that you're not going to just see 1 year. Maybe if you did for 5 years in the same spot, you would have an issue. For beans, if it's 15-inch rows, we do plant them between the 30-inch rows, so they're whatever 7.5 inches off the strip, so they're fairly close to the strip. But we also plant beans with a drill now, and we don't see much, like you don't pick out the strips with solid seed beans either, or the wheat the year after, that's for sure.
Right. I guess, Ben, you had any comments on that? I guess you'd move around a little bit on their trials, right?
Yeah, so in our trials, I don't have much to say, but talking with growers, I think for sure if you're on low testing ground and fertility is not being addressed in those other crops, those strips would show up, in wheat or beans in following years. I'm surprised in the number of growers if they're in kind of a corn, soybean, wheat rotation, or maybe corn, bean rotation too. Ideally, they would like to go back on that corn strip again once corn is back in the rotation from a tire traffic perspective, a soil fertility perspective. But yeah, I think growers that are doing that, staying in corn always in the same spot in their rotations, they're addressing fertility needs in the other crops, like putting MAP with the wheat when they're planting or broadcasting head of beans if they are on low fertility ground to make that work.
Yeah. So this visitor to the webinar today is on ground that gets dry manure, and his fertilizer needs are met with the dry manure. He's got fairly built soil fertility. What's our comments about how strip till fits on a farm where there's a fair bit of dry manure and his soil test levels are elevated? Ben, you want to tackle that?
Yeah, I guess, strictly from a soil test perspective, if you've got elevated soil tests, maybe, and, levels that we wouldn't expect responses to, maybe fertilizer is less important. If that represents all of your corn acres, maybe there's less importance there, or maybe you could get away with, an in-furrow program on the plant or something like that if you are truly built, and that represents most acres, and there's not acres out there that are low. Maybe that's one of the few scenarios where fertilizer is less important in a strip scenario.
Right. Any comments, Mike?
Yeah, it depends. Like if it's correct and you get away with it, just saves a lot of money in your strip tiller, I guess too.
Yeah. So question from Paul to Mike. When you do your plots, is in the middle to the end of the season or the beginning of the season? Where does it? I guess he's wondering a little bit about your starter response and whether it matters whether you do the plots on the first day you're planting corn or the last day you're planting corn. Any comments on that, Mike?
I wouldn't say I see it on particular first planted, last planted corn. Our plots go on every farm, just the way we do it, something like that. You just leave a couple strips on a 100-acre field for a starter plot. So we do it on every farm. I wouldn't say we see a difference if it's the first planted or last planted or middle corn. I have never been able to pick that out. It seems more of anything a yearly thing. I've been finding pretty consistent responses more in the year. And normally we plant our corn like a pretty dragged out season, like on the earlier side to prime season. We don't try to be the first guy to have everything in, but we do try to split our risks. So we try to start earlier and finish in prime times.
Right. Any comments from either one of you? Given what we've talked about here this morning, your comments about the discussion around sort of liquid application technologies, whether that's splitting the stream in the furrow or adding liquid capability to either side of the row. There's a bunch of equipment. Precision Planting has some equipment to finesse or reposition the liquid bands, either in furrow or to the side, different coulter setups. Sort of an open-ended question, but I'd like both of you to take a shot at it. Where do you think this sits in your experiences or research when we talk about trying to get more out of the positioning of liquid bands?
Yeah,
Mike,
I
have
guess
you looked at or sorry, Ben, go ahead.
Yeah, I was going to say I am from a splitting perspective. I'm not sure it's much more from a response perspective, but the ability to put more on safely, certainly from a safety perspective. If you're splitting bands and putting two bands on, I think you've got an option to run more product safely than with a single band. Again, I'm speculating. I have no research. I haven't looked into it, but I'm guessing from purely a fertility response perspective, I'm not sure there would be much more there without doing some trials.
Right. Mike, any comments on fancy liquid banding?
Honestly, we haven't really looked at it because our goal is to try to get the fertilizer off the planter. So I don't want to make myself want to put it on. So.
Right, right. I hear you. So of course, Paul would ask the question, because that's the sort of guy he is. Is there a hybrid interaction with fertilizer placement? And I know that's really not something that we've talked about this morning, but do you get more response from some hybrids when you do a spring strip or starter fertilizer strip? Ben, I'm assuming you're running just single hybrids anytime you do a trial, obviously because of the restrictions of size. And Mike, do you have a comment on whether you think some hybrids respond more to a different fertilizer package?
No, I don't think I've ever picked that up on it. Maybe a little bit more of some hybrids. Some have a better start maybe on those colder, wetter soils, so maybe they get a little bit nicer start on it, but I haven't seen any like huge differences from one hybrid to another hybrid. It's not like when you say, hey, all these plots work good and they're all one hybrid.
Right.
And I haven't really ever picked that out. So
Yeah, fair enough. That's so a question here, Mike. Do you have any trouble with sort of blowouts in the fall strip till? You mentioned about how critical it was to keep it uniform. Any concerns about soil moving outside of the trench in your fall strip till operation?
yeah, no, the odd time we'll have a strip washout. It's not like, let's say we have a side hill, we have some steep hills. It's not like every strip's washed out. You might have one that it decided to find the path on and wash it out.
Right.
It's not like it's a 10-foot washouts. You just maybe lose a little bit during the strip, but nothing major, nothing to stress about. Sometimes in high wash areas, we'll lift over top of it and drop back down if we think it needs it, but we don't generally worry about it too much. You might get one strip washout, but it depends on the year in the spring, but not always in more of the farm. But yeah, the odd time you might have on a really steep hill, you might lose one strip.
I think to follow up a little bit, when we first started strip tilling, it was an anhydrous knife with two discs sort of attached to the bank of it, to the back of it, right? And it was more difficult to create the uniform strip than it is today, where we have more you sort of options, adjustments, coulters, equipment to sort of refine or contain that strip compared to where we were, well, sort of a long time ago when it really was an anhydrous knife with a couple of hillers on the back of it, right?
Yeah, no, for sure. Like even our new strength, so we had a coulter strip tiller before this, and my new shank strip tiller has more coulters on it per row than when I just had a coulter strip tiller just to keep all that dirt in, right? So
yeah,
they got, yeah, I think we have 1, 2, 3, 4, 5, 6, 7, 9 bearings per row on our shank strip tiller.
I was going to say it's a bearing. It's a yeah. Hey, we're getting them whittled off here. The comment is there much risk to losing P and K nutrients from a fall strip application? And so I guess that's maybe a bit speculation on all of our parts, but not a bad question. What's the advantage in terms of P and K retention, or not losing P and K in a fall strip system versus conventional? Any thoughts from either of you on that one?
Like from a phosphorus perspective, we don't usually think losses are going to be too much, assuming you're getting it in the ground, mixed in that strip and not leaving it on the soil surface. I know from a potassium perspective, you can talk to some guys on probably, generally, again, maybe not big issues for losses, except talk to some guys on sharp, deep sands that say they can't seem to build potassium levels in their soil. So maybe that's a concern if that affects you. I wonder just more from an efficiency perspective, if you're putting on the spring and you're really, really low testing soil, you're not giving time for that fertilizer to react and get attached to soils. If your soil tests are low, if that's maybe an issue more so than losses, but again, maybe a bit of speculation, but that's kind of where I would go on that question.
Any comments, Mike, about the efficiency or the loss potential for P&K in a zone versus other options?
No, I think most strip tillers do a good job incorporating in, like Ben says, like it's not like, I don't know if it's mixed in nicely, not on the surface, like it has lots of soil to like stick to, right? And I wouldn't say, yeah, there's a big difference between fall and spring, as long as you're applying it properly or anything else,
Yeah,
right?
yeah.
So,
I think in the whole issue around phosphorus, we do appreciate the need to band it, to not broadcast it, and the strip tiller does give us, I think, an advantage on phosphorus management where we can get away from any sort of broadcasting, if for the most part, right?
yeah.
So that's great. I think we've pretty well got through all the questions. So our final wrap-up question is: so, and we've we've danced around it. I think we've thrown out some good information in the final analysis. If you have your strip tiller laying down the fertilizer, can the planter run free of fertilizer? But Ben, where you at there? What's our final suggestions in terms of advice to growers moving, maybe if they're thinking about a strip till system, to answer our question for today, in a strip till system with fertilizer, can the planter run free?
Yeah, so I think there's lots of cases where we've shown it can work, but there's still the data out there that it's still showing some response or fertility on the planter. So I think it would come down to some of those factors we talked about earlier, like soil test and placement in the strip and that sort of thing. If you think you've got a lot of those covered, but you're still not sure, because even some of our data points showing responses are things where you maybe wouldn't expect to see a response. Trying to do some trials on farm, kind of like Mike had, to give yourself that confidence on your farm that it won't give you a response. That's kind of where I would go on that.
Yeah, Mike, final comment on can the planter run free?
Yeah, I think getting close, let's call it that. So I'm not sure, I'm not 100% comfortable there, but I'm very close to making that decision. I think it can run free, but I do think it depends on the farm and your soil levels. I think if you need to get more fertilizer down, the planter is still a good option to put fertilizer down. But if your soil levels are good and you get enough down your strip tiller, I think the answer can be yes. But again, it's very dependent on the farm and economics too, because some of these big planters are quite expensive to put dry fertilizer on anymore. So I
Yeah.
need more of a yield bump from it than you first think when you start running the numbers. So
Yeah. Well, and people know my thoughts. I keep the data is always trying to keeping us honest, but I'm of the opinion that it's a great place to go. That if you could get your planter more simplified, because you've invested on the strip till side, I can't help but think that that's a good place to go. So this has been great. Thanks to all of you who have joined us for the webinar today. And of course, thank you to Ben and to Mike for all of your insights and comments and the plots and research you've done. So we really appreciate it. So we're gonna sign off there. Just a reminder that next Tuesday will be Dr. John Fulton from the Ohio State University, talking about precision agriculture and return on investment for precision agriculture. So thanks to everybody for joining us today. Again, thanks to Ben and Mike, and we'll see you next Tuesday, 10 o'clock. Take care.